Okay, let's go ahead and look at our warm-up here. If I were to follow just the setup that you use for slope formula, y2 minus y1 would look like 4 minus, but I don't know what that is, so 4 minus y over 1 minus 3, and it's supposed to equal negative 3. So then I just have to solve this for y. First of all, 1 minus 3 is negative 2. And then it's just back to algebra 1 solving equations, right? How do I solve this equation for y? Well, there's a couple steps to it. We start by getting rid of that negative 2, right? So I multiply both sides by negative 2. Oops, negative 2. I subtract 4. And I divide by negative 1. We get y equals negative 2. Okay? Any questions on that? That was 79. I can do 80 real quick. Yeah, so that was the, yeah, because of the 1 here and the 3 here, the different x values on that. I am going to do and give you the correct answer for 80, but same idea. Okay, now I could go the other order, and if I go the other order, it means that I wouldn't have a negative in front of the y. You can go this y minus this y over this y minus this y. You could do that, right? Because we are the ones that pick which one is 0.1 and which one is 0.2. So maybe I want this to be 0.2 and this to be 0.1. That's fine. It just needs to be y minus y over x minus x. So I could do that. Y minus negative 4 over negative 2 minus 4, and that's supposed to equal 1/3. And again, solving then that for y, clean up the bottom, multiply by negative 6 to get that out of the bottom. Negative 6 times 1/3, which would be negative 6 divided by 3, is negative 2. Minus 4 is negative 6. Would be your second answer there. Any questions? All right, as we transition into where we are going to take our notes today, I will tell you, based on the fact that you get to use your notes on your unit objective quizzes, it is indicating to me that some of us might need to improve our note-taking process, because we're missing out on some key things that we should be able to just go reference in our notes as we take those quizzes. And we're forgetting those things as we're taking those. And so that's what the grading of the quiz is telling me a little bit. With that being said, I do have those quizzes ready to show you today. We'll do that during work time so that we have more of those tomorrow, which you're going to make sure that you took good notes yesterday. You're taking good notes tomorrow so you can use that on your unit objective quiz, and then studying for our test on Friday, which will not be with notes. So reminders as well as before we get into this, as you're getting your notes set up, ready to go, that your test on Friday, part of that, which you guys have seen on your unit objective quiz, is me asking you, do you know how to use your calculator? Have you been trying the things as we've gone along to make sure? So coming up to me and saying during a test, I don't know where the absolute value is on my calculator, is not a question I'm going to answer, because if you've done the in-class, if you've done the homework, I would not ask you anything that we have not seen on there, okay? So please make sure that you're doing that, and understand I'm not trying to be mean to you, but that is the point of my question, is have you learned this? At the point, that's what a test is telling me. What do you know? Also, I have started, some of you noticed, I have started putting in homework grades. I am going to go back and get your homework from previous as well. That will just take me a little longer because I have to look through each individual one. What I'm going to do is the homework that was prior to my math lab is I'm going to give you completion. So if you've got all the work on there, you get your completion grade for that. My math lab, what you're noticing is that I'm matching your grades kind of, approximately, grading it out of 10 for each of your assignments. Here's my plan. I'm going to try to keep PowerSchool a little bit more up to date. But on the day of the test, that is the last day that anything from that set of sections will be allowed to be turned in. So right now you can turn in anything from 1.1 to 1.5, which is what you'll get assigned today, by Friday. So if you on Friday have gone back and you're like, ooh, I did really bad on that assignment, and it's now sitting at like a 3 out of 10 in PowerSchool, what I'll do on the test day or a day after the test is go back, and if you have updated anything, you can submit something late. It'll dock you a little bit, but you could improve your grade, especially if you get like a 3 out of 10 or something. Go back and fix some things on that and earn some points back, and I'll just scan through and make sure that you haven't updated, because it doesn't notify me of updates, unfortunately. But I will set the final submission date as your test. So you can do anything late to earn points back, to if you've missed a due date, it'll still give you credit for it, guys, until the test. And after the test, you are locked out of those. You cannot go back to them. So Friday is your day. Make sure you have it done by then, okay? And if you are thinking that something is incorrect on there or having concerns on there, please talk to me. This is all a learning process for all of us, okay? So don't hesitate to talk to me about that. And if after the test it doesn't look like I have updated something to your new current grade, just give me a heads up, okay? All right, to our last section. 1.5, after today you have learned everything in this chapter. We will review tomorrow. We will review on Friday and test, or Thursday and test on Friday. Again, today is going to look like some familiar material. You may recognize some of these words, or you may even remember the entire concept. The first of those is what parallel lines are. Now, there's some tiny little things in the definition of parallel that I do want to point out. I very much simplified the definition, but it says two distinct lines with the same slope. Why the word distinct? It means two different lines. If I were to draw two lines that were on top of each other being the same line, they're not parallel, they're the same line, okay? So that's why the word distinct. What I kind of simplified out of the definition of parallel is the fact that in your book it talks about them being non-vertical lines, okay? Now, two vertical lines are parallel to each other if they're different x values, that they are like x equals 2 and x equals 5. Those really are parallel lines, okay? But if you are very, very strict with your mathematical definitions, vertical lines don't have a slope. You guys remember we talked about that the slope is undefined or considered no slope. So when they say that they have the same slope, well, if they don't have a slope, how do they have the same slope? That's the like super, if I'm really adhering to mathematical definitions. Now, I don't think that that's worth clarifying the difference between. Vertical lines are parallel to each other as well, okay? So don't get confused by that when it talks about two non-vertical lines. Vertical lines can be parallel too. Okay, so looking at things like that, we will be asked a lot of times to write the equation of something parallel to a line that is given to us. Now, in this particular example, we are going to go through this point right here. -2, 5, and we are going to go through the equation that is, parallel to the equation that is y equals 3x plus 1. Now, we're going to talk about some variations that can happen. This point could be handed to us, or we could get it from a picture. Maybe we have to look at the picture and get the ordered pair. This information can be given to us in several different ways, in point-slope form, in slope-intercept form, in general form, or in a picture. But what do we need from this? We need its slope. Okay, so it doesn't matter what form they give it to us in. We probably want to move it to slope-intercept if it's not handed to us in that, but we really ultimately just need the slope from whatever we are supposed to be parallel to. However you get that slope, if it's a picture, you can just count. If it's point slope or slope intercept, we can just pick it out of the equation from the right spot, but unfortunately, we'll see on the next one, if it's in general form, we have to do a little bit of work. But we need its slope, and in this case, its slope, because this is in y equals mx plus b, its slope is 3. That's what I need to know from whatever I'm supposed to be parallel to, okay? So we want to go through that point. Because it is parallel, they have the same slope. I'm going to use the slope of 3, similar to the line they gave me. And then it asked me to write our equation in point slope and slope intercept, which is nice because point slope is where I start. Slope intercept is my 2-step move away from that equation. So here's my point slope. y minus, and remember we're using this point up here, so y minus 5 equals the same slope as the equation they gave me, so 3. X minus negative 2, which looks like plus 2. And then we do 2 steps and get to our slope-intercept form. Remember, it will always be the same 2 steps. I will distribute, I will add or subtract to get y by itself. Always. That's how you get from point slope to slope-intercept every single time. So job number 1, distribute the 3 through. And then job number 2, get y by itself. And there is my slope-intercept form. Any questions on that? Or parallel lines in general? Okay, so again, remember our variations. We need this information. We need to know what point it's going through. We need to know what slope we're parallel to and the different ways that we could get that. Maybe I have to look at where that point is on the graph because they say go through point A. Maybe they hand me this in a different format like point slope or general form or a picture. Ultimately, all I need is its slope. So think about how we get the slope from an equation given to us. Perpendicular lines is then the other topic typically associated with parallel lines because it's when lines have a relationship to each other. And it says 2 lines are perpendicular if their slopes are opposite reciprocals of each other. Just in general, what does this mean? It means that 2 lines meet or intersect specifically to form a right angle. So anytime that 2 lines are going to intersect to form a right angle, they are considered perpendicular. In terms of equations, what do we need? We need to know that their slopes are opposite reciprocals of each other. Now, what does opposite reciprocals mean to us? It means that we turn our fraction upside down as the reciprocal part. And the opposite means we change the sign. So change the sign from positive to negative or negative to positive is the opposite part. Reciprocal part means turn the fraction. Upside down. Now, I put the word fraction in parentheses. If I told you that the slope was 3, that doesn't look like a fraction, right? How do I make something look like a fraction if I needed to? Over 1. So that's why I put it in parentheses, because I said turn this fraction upside down, and if it doesn't start looking like a fraction, I would want to flip that as I go. Okay? So write the equation line passing through. So again, they directly give us the point. We want to go through this point. So there's my x1, y1 for our equation when we get there. Perpendicular to the line whose equation is x plus 3y minus 12 equals 0. Ooh, what do we need from this? We need its slope, right? So we need the slope. This one is in general form, which is not super obvious to find the slope. So in this case, we're going to need to move it to, I would move to slope-intercept, solve for y, okay? So we do have to do a little bit of work on this one. To solve for y, which is right here, I would add 12 and I would subtract x. I would divide everything by 3. Okay, let's look at this. Negative x divided by 3, remember it's the numbers in front. It will be easiest on this if we slide that x to the side. We're going to take it a little side note here. We're going to do a couple side notes today. Here's your first side note. Let's zoom in on this thing. I just had negative x divided by 3. Guys, anytime you have something like this, if you have a variable that is sitting in the top of the fraction, I can slide that variable to the side of the fraction and just leave whatever was the coefficient of it. Well, the coefficient of the x is a negative 1. So this would be equivalent to a negative 1 over 3 with the x slid to the side. And a lot of times we're going to want to do that for our purposes, is slide that x out of there so we can see what number is sitting in front of it. Okay? All right, back to this. That's why I got the negative 1/3. I slid the x out of there because I want to know what the slope is. And the slope is negative 1/3, right? It's what's sitting in front of x. Now, we are supposed to be writing this equation in as perpendicular to that. So because my line is perpendicular, there's a geometric symbol for perpendicular. Do you guys remember that symbol from geometry? Because we want to be perpendicular to our equation, we want to use the slope, turn this upside down, and change the sign. So positive, turn 1/3 upside down, positive 3 is the slope we will use. Questions on that? Again, just so you know my notation up here, I use the geometric symbol for perpendicular, so I didn't have to write the word out. You don't have to know that symbol, but you can use it if you want. Because we're perpendicular to this equation, we're going to use the slope of 3 through that point. Now I go to writing my equation. Start in point slope, but it asked us to write our equation as general form. So eventually we'll put our x, y, and constant all on the same side, but you've got to start in point slope to begin with. So start in point slope. Which would be y minus our y value of -6. So y minus -6, our slope. X minus -2. To get to general form, we're going to have to distribute, then just move everything to the same side. I will always make my x value positive, so I'm going to move whichever side would make my x value positive. Okay? So as I distribute here, I see my x is positive over there, so I'm just going to move everything to the right-hand side and keep that x positive. So to do that, I would subtract y. I'll do this in 2 steps here. And I would subtract 6 to move everything to the same side. But actually, your 6 minus 6 is gone, so you wouldn't have a constant listed after that. There's your general form. General form. So again, a little note on our decision-making process. It's going to be easier to just move it whichever direction would make the x value positive, because typically in general form your x value is positive. So I chose to move mine to the right for that reason. If it had been negative, I would have picked to move everything to the left, because then that would have added it over to the other side, making it positive again. So that's how I make my decision at that point. Any questions for me on perpendicular? Okay, make sure here, before we move on, I'm going to add in again a little side note here. Here's our last side note, just so that you know. If we were talking, let's say we had a horizontal line. First of all, what's the slope of a horizontal line? 0, right? Has a slope of 0. And let's say that's up at like 2. So the equation of this line would be y equals, right? All horizontal lines are of the format y equals. And its slope is 0, so this is the equation y equals 2. What if I asked you that I wanted you to be perpendicular to that line through the point 1, 5? Okay, well, first of all, what kind of a line is perpendicular to that? An undefined slope, vertical line, right? And if it's an undefined slope and a vertical line, what's the equation look like? X equals whatever x value of the point we're supposed to be running through. Okay, so just in general, vertical and horizontal lines are perpendicular to each other. Now, the whole opposite reciprocal thing, then look at the difference in their slopes. Vertical is undefined, horizontal is 0. Does that make sense? Well, this was some number over 0, and this is 0 over some number, and if it's 0 or undefined, does the sign on it make any difference? No. So really they are opposite reciprocals of each other, but they're the words undefined or the number 0. So they're kind of a unique case, but they are perpendicular to each other. Any questions on that? All right, then we're going to move on from that. Slope shows up a whole bunch of different ways, and especially, again, if you were to go on to any sort of calculus course. Now, that might be my juniors that are taking calculus next year. That might be my seniors that are going into business and are going to have to take a business calc next year. You may find yourself in a calculus class even if you are not a math major. Well, why am I telling you this? Because in calculus, the concept of average rate of change shows up a ton, but it's just slope. But it uses nice, fancy mathematical notation to describe slope, and so it looks intimidating. But if you remember when we talked slope, I wrote this on the board, right? Change in y. That triangle is your mathematical symbol for change in. It's read as delta. Delta y over delta x is the change in the y values over the change in the x values. Now, our mathematical notation is f of x2 minus f of x1. Guys, remember, f of x is just your y value in an ordered pair, right? There's my x1, y1. There's my x2, y2, but it is specifically a function, so we could write it in function notation. So this, again, is just your slope formula. Here's your y2 minus your y1. So it is no different. It just looks fancy, right? On this, I will tell you that it is finding the average rate of change on a function that is not linear. But we're drawing a line to connect those 2 points. That line has a name. It's called the secant line. So this blue line that we drew in here is called the secant line. It just connects 2 points. Any 2 points on a function between whatever x values they tell us. Okay? Now, in this book, it also talks about average velocity. They change up the lettering on you, and they usually call it like s of x. Again, it's just fancy mathematical notation for your slope formula. So you're still plugging it into the formula and doing y2 minus y1 over x2 minus x1. Okay? Don't get like intimidated by all the fancy notation that you see. Any questions for me on that? Okay, so let's look at how this can look a little different, but still be the same thing. Find the average rate of change, which again is a fancy phrase for find the slope. And they give us a function, f of x equals x cubed. Here's what's going to be different, is they're going to give us an interval to look at from x sub 1 equals 0 to x sub 2 equals, negative 2 to x sub 2 equals 0. Well, they're giving us the x values of an ordered pair. We're used to seeing ordered pairs and then putting them into our slope formula, right? Slope equals, and we do y2 minus y1. Well, all they're telling us is the x values. One of them is negative 2, one of them is 0, and now I have to go plug them into my function to figure out the y value, or the f of that x value answer. So to fill in here, I will do f of negative 2. And f of negative 2, I'm plugging that into my function, is negative 2 cubed. I put that answer in this spot right here, and negative 2 cubed is negative 8. F of 0 is 0 cubed, and 0 cubed is 0. Now, you can go about it this route, is write out the ordered pairs. You can also just do the mathematical notation, which would have been f of negative 2 minus f of 0 over negative 2 minus 0. That was the formula. That's your slope formula that they just showed on the last page. Well, f of negative 2 is your y minus f of 0, again, is your y over negative 2 minus 0, x minus x. Any questions? So if you like this method of just writing out your ordered pairs and then jumping to your slope formula, do that. If you like setting it up this way, do that. It's the same thing. Okay? Negative 8 minus 0 is negative 8. Negative 2 minus 0 is negative 2. And negative 8 divided by negative 2 is positive 4. Any questions? Now, I don't think I have an example. Oh, I do have an example. Nope, this one still says as average rate of change. If they were to change that word to average velocity, remember it's the same thing. You're evaluating. Now, on this one, it does give you a picture. It says when a person receives a drug injection into a muscle, the concentration of the drug in the body is measured in milligrams per 100 milliliters. It's a function of time elapsed after the injection in hours. Find the average rate of change of the drug's concentration between 3 and 7 hours. Okay, so in this, they're saying between here and here. Well, we're just going to consider this a line connecting those 2 points, and you're finding the slope of that line. Use this point and this point. So again, this whole average rate of change, fancy ways for saying find the slope between those 2 points. Easy enough? You guys find it. I don't know what that is. I'll make those numbers bigger for you. And again, they have to talk about it being the average rate of change, or eventually you'll see some that ask you for the average velocity, because it's not a linear equation. So it's not the slope necessarily of the function. It's the slope of the secant line just connecting any 2 points. So I made this my second point. Then my first point I did 0.02 minus 0.05 over 7 minus 3. Any questions on that? If you have that in the exact opposite order, top and bottom, we'll get the exact same answer, okay? Negative 0.02, or 0.02 minus 0.05 would be negative 0.03. And then I don't know what that is. Who's got that on the calculator for me? What do you got? 0.0075. All right. Questions? Okay, so again, finding ways to recognize that these are all different ways of asking you to find the slope. And when it is not a linear equation, it's just going to be the slope connecting any 2 points that they happen to identify for us. Ignore the rest of the loop-de-loop going on around it. All right, I did tell you that they would say it in a different way, and this one again is an example of that. It says the distance s of t in feet traveled by a ball rolling down a ramp is given by the function s of t equals 4t squared, where t is the time in seconds after the ball is released. Find the ball's average velocity. Again, average velocity, same idea as average rate of change, which is, again, the 2 fancy ways of saying the slope of the line connecting those points. They're all the same formula. And then it gives us the times, from time equals 1 to time equals 2 seconds. So if I follow my fancy mathematical way of setting this up, I would say they called their function s. So I would say s of 2 minus s of 1 over 2 minus 1. I'm going to show you the fancy way first, and then the more slope formula looking way second, okay? Now our function s is 4t squared. So if I plug this into that, I would have 4 times 2 squared for that first part, minus, plug 1 into it, 4 times 1 squared. Let's see, 2 squared is 4, times 4 is 16. 1 squared is 1 times 4 is 4. 2 minus 1 is 1. And 16 minus 4 is 12. Again, if this formula is just kind of messing with your head, option 2 would always be to do this. Make this your x1 and your x2. Go to the formula to figure out what it is when I plug in 1. If I plug in 1 here, I get 4. If I plug in 2 here, I get 16. And then ignore everything else going on and go put that into your y2 minus y1 over x2 minus x1. Okay, so if you like that better, just write it out as the ordered pairs and do your slope formula. If you are comfortable with this, it just kind of saves you a step of writing out ordered pairs. But you get the same answer. Okay. The trick is you have to remember that the numbers they are giving you are your x1 and your x2. To start your ordered pairs, go plug them into your ordered pairs. Questions on any of this? Anyone still want this page? All right. And again, we are going to, I know I skip this often, I apologize, but we are going to